Okay, welcome back. And I wanted to go back to this example that I just finished in the last video because I wanted to do it another way that is also done in the textbook, which is just fine using a table. So I'm going to start off with where we left off with the factors, and we had everything that was plotted. Okay, so I'm going to come back to this before I sketch this. Okay, so we have our intercepts. Okay, so let me just plot this back here. Okay, so we had our intercepts. Okay, so now we know that it crosses, based on the last conversation, we know it crosses at each one of these because of the multiplicity. Okay, we also know with the end behavior that it has to be doing something like that. Okay, but how do we know what's going on in between? Okay, that's where you can do a sign test. Okay, and so what you do is each intercept creates an interval. So now you've got what? 4 intervals for the graph. You've got this one. So what's going on in this interval? So let's set up the table this way. So our intervals. You can set up the table differently. Let's see. Okay, so we can go from negative infinity to the first one, which is going to be at negative 2. And then the other interval is going to go from negative 2 to negative 1.5. And then the other interval is going to go from negative 1.5 to what? To 1. And then from 1 to positive infinity. Okay, now these are the intervals. Okay, now we need a test point, right? We want to have some sort of test point that we can use. Well, we want to use something simple, so but close, not too big, but something that'll work. So in this case, negative 3 would be the best option. So negative 3. Okay, and in this interval, what would be a good test point to use? Well, let's use let's see. Because that's a. Let's see. Well, I guess we're not going to be able to get away with anything simple here. So this is negative 3/2. So let's do. Negative negative 1 3/4. And then between, here, this is an easy one. We'll use 0. And then here we'll use 2. Okay. And so what we're going to do is we're going to find the value of the function at each one of those points. Again, so what we're doing is we're picking an x value on each of these intervals, and we're going to find what's the sign of the function. So what is f of x at those? And here we're not really too interested in the actual value of the function. We want to know whether it's negative or positive. Why is that? Because we want to know if the graph is above the x-axis or below the x-axis. That's really what we want to know. Okay? So in this case here, if negative 3, if I put a negative 3, then what happens here? If negative 3 is put in here, this becomes negative. If I put negative 3 in here, this becomes negative. If I put negative 3 in here, well, this becomes negative. So a negative times a negative times a negative is negative. So we know we're below the x-axis. Okay? Now, I just want to make sure. Yeah. Now you can put these in the, if you want to plot these points, you can put them in there like the textbook does, but it's not always necessary to do that. Now I'm going to stick in this one. Okay? So if we put in 7/4 or negative 7/4, so again, all I want is, so this is negative 1 3/4, so negative 1 3/4 minus 1 is still going to be negative. Negative 1 3/4 plus 2 is going to be positive now. That's going to be positive. And then negative 1 3/4 times 2, well, what is that going to be? Well, I'm doubling my value, so that's going to be actually 3, okay, which is going to be a negative, it's going to be bigger than 3, negative, okay? And so this will be 3 and negative 3.5. So this is going to be negative. Oops, I don't want to erase that. And so if I do it again, negative times positive is negative, times negative is positive, so that means I'm going to be above the graph. So this is going to be positive. So how do I label this? So this is going to be below, above. Okay, 0. 0 is easy. I plug in 0, I'm going to get negative 6. So that's an easy one. That's our y-intercept. So we're obviously below the graph on that one. Okay, so, but again, if you want to see 0, this is going to be negative, 0, this is going to be positive, 0, this is going to be positive. And so it's going to be negative. And so we're going to be below. And then finally, if we stick in 2, well, 2 is going to make this positive. 2 here is going to make this positive. And positive 2 here will make this positive. So that means all positive. So I'm going to be above. And notice again, as we do this, we get the exact same result. Okay? So again, I'm going to be below the x-axis. So from this point, I'm going to be below. And then when I cross, we know it crosses here, so I'm going to be above. And since I know I'm going to go below here, on this interval here, I have to turn, right? So there has to be a turning point there somewhere. And then I come down here. So I get the same result. So again, you could use the table to help you graph this as well, because again, you know it's going to cross. So we knew it's going to cross at each one of these 3 points. And now that we know with the interval, we know that it's going to be below the x-axis on this interval. So that's what we got. Then it's going to cross. Then it's going to be above the x-axis for the second interval from this point to this point. And so it has to turn, because after that point it goes back below. And then it turns, let's say over here, and it has to come back up because at 1, it goes positive again and stays positive for the rest of the graph. And that's it. So there's another way of graphing the polynomial function using this sort of table. Okay, have a great day.